Kevin Anderson, welcome. You are the Deputy Director for the Tyndall Centre for Study of Climate Change at the University of Manchester, and you are here to help us understand and define some of the challenges of climate change for doing our research and doing our programming.
Well, thank you very much. Well, I've called this talk Climate Change Going Beyond Dangerous, and I'm using that as an expression because in my view and the view of my colleagues and the conclusions from our work is that we are now in the process of going beyond what we have traditionally called dangerous climate change, and I'll define that and talk about that a little bit more during the talk. And if you like, the subtitle for this is Brutal Numbers and Tenuous Hope. The maths, the quantification behind what I'm talking about here is unappealing, to say the least. The numbers are brutal, they're hard, they're not numbers that we want to hear. And if you look at those numbers and you start to translate those into what that means for us as a society, then you realise there's very little hope. There's tenuous hope of actually making substantive changes in the time frame that we have available. But we need to say that. If that's the situation we're in, we need to be honest about it. And then once we're honest about it, we have some hope of making change. If we're not honest about it, then we can do nothing. Or, of course, we can carry on with what we've been doing for 20 years. Cognitive dissonance, a fancy academic term for hypocrisy, where we stick our head in the sand and we pretend things are not going awry. And they clearly have been going wrong for the last 20 years. The Earth Summit was in 1992 in Rio, and all we've seen with emissions since then is them rise year on year. Not only rise, but the rate of growth of emissions has gone up. So we have done absolutely nothing in relation to climate change over the last 20 years, and we need to be true and honest about that now in 2011. So that's the sort of backdrop to this talk, and the tenor will certainly be often quite downbeat, but I also think there are some real strong messages of hope about what we need to do and how quickly we need to do it, and that actually it is still doable. So what I'm going to try and do over the next 40 minutes to an hour is to explore the void and the rhetoric, between the rhetoric and the reality on climate change, particularly focusing on mitigation, on reducing our emissions. So we have a lot of discussion about reducing emissions, but what's the difference between that discussion and what we all claim we're doing as individuals, as companies, as nations, as a global community, and actually when you start to look at what is actually happening in terms of emissions, what's the gap between the two, and what can we do to bring the two together to remove that gap? I spend a lot of time talking to companies and organisations about climate change, and they'll say, "Oh, we're doing something about climate change," and I think it's important to say, "Well, what do you think climate change is? What are you responding to?" And it's this sort of woolly, nebulous term, "I'm doing something on climate change. I bought a slightly more efficient car." That has nothing to do with climate change if you drive it further. So we need to think quite carefully about what are we doing as organisations, as individuals, as governments about climate change. What are we responding to? And for me here, it's actually quite simple. I will simply use what we have said internationally and nationally is the goal of all of this climate change research and policy that we're apparently undertaking. So if we think now internationally, the Copenhagen Accord that came out of the major meeting in December of 2009, the Copenhagen Accord is very, very clear, and it now has over 120 countries as signatures to the accord. And it's to hold the increase in global temperature below 2 degrees Celsius and to take action to meet this objective consistent with the science and on the basis of equity. And I think that's really important. It's a very clear statement on the basis or consistent with the science and on the basis of equity. So this is a really important backdrop against which we can then think about what we need to do in terms of policy. But if we then go to the EU repeatedly makes statements such as this one here. The EU must ensure global average temperature increases do not exceed pre-industrial levels by more than 2 degrees C, and it says we must introduce the appropriate domestic measures to ensure that is the case. Or if you go to the UK's low carbon transition plan, average global temperatures must rise no more than 2 degrees centigrade. Now, these are not a 50-50 chance of 2 degrees centigrade. Whether it's the Copenhagen Accord, the EU or the UK, they must rise no more than 2 degrees centigrade. And that is really important. That probability of 2 degrees C is actually there's a lot of smoke and mirrors around that. So people say we must rise no more than it, and then introduce policies which mean you've got about a 1 or 5% chance of actually staying below 2 degrees. So there's a big difference between what the language is saying and what the actual policies are doing. So the question is clear. How do we ensure a good chance of staying below 2 degrees centigrade? And I'll just quickly say what I mean by 2 degrees in case some people aren't so familiar with it. 2 degrees C is the global temperature rise compared to the pre-industrial period, and it's a global mean surface temperature rise. So it's basically looking at the temperature before we started to burn fossil fuels, and then as we burn fossil fuels, the temperature starts to go up. And the argument is that we could cope with a global average increase of 2 degrees C. And that sounds, particularly if you live in the UK, that doesn't sound too worrying. You think, well, it'd be quite nice to be 2 degrees C warmer. The regional repercussions of that are very large. In the poles, you might see up to 7 degrees or so with a 2 degrees C warming. You'll certainly see some very large changes in temperature around the globe in different regions for an average of 2. Remember that 2 degrees C, of course, is the whole globe, and most of the planet is covered in oceans, so you'll probably see a 3 degrees C or so on average on land, as I say, up to 7 degrees in the poles, with big changes in precipitation as well. So 2 degrees C will have much larger repercussions than we may immediately think when we think of 2 degrees C temperature. So why have we come up with this number of 2 degrees? Well, it has actually been talked about on and off for probably about 30 or 40 years now. But broadly, what's happened is the scientists have looked at the impacts related to 2 degrees and indeed other temperatures as well. And they've come up with what we could call a managerial tool. They've taken all of the work that's been conducted on impacts and pulled them together into 5 categories of impacts, and then they've coloured them here, as you can see, from sort of the white colours up towards red colours, and as usual, as you head more into the red, you're heading more into the danger zone. And you can see for this set of collective impacts, the difference as the temperature goes up, you enter more and more into the red zone. And what's happened is that the process of policymakers engaging with scientists, engaging with companies, with organisations, engaging across national governments, over time we've come to think of this 2 degrees C guardrail as above 2 degrees C is considered dangerous climate change, where the impacts are no longer not acceptable. And below 2 degrees C, we may not want those impacts, but we say we could just about live with those. We could tolerate that set of impacts. Now, what's really important is that first assessment of the impacts was made in the late 1990s and the early 2000s, and here you can see it's published in 2001. These were revisited at the time of Copenhagen in 2009, and what you see straight away is the science has come a long way. A lot more is understood about the impacts, and worryingly, a lot more of those bar charts now, those collective impacts, are red. So the impacts will occur at much lower temperatures than we thought before. And if you actually plotted what set of impacts we thought before was just about acceptable, if you plotted them now, you'll notice they occur at a much lower temperature. So as an academic who's not interested whether our work is liked or not liked, there is a very clear conclusion that comes from that. If 2 degrees C was dangerous before, the impacts now at 2 degrees C are much larger than we thought at that time. So is 2 degrees C the threshold between dangerous and extremely dangerous, rather than between acceptable and dangerous? So 2 degrees C is likely to have much more impacts. You could argue is 1 degree C the new 2 degrees C. Certainly it's hard to argue against that from a logical point of view. From a practical, political point of view, given that we put so much emissions into the atmosphere, it is actually hard now for us to imagine actually holding a temperature to 1 degree C. Even if we stopped all emissions now, we would likely go above 1 degree centigrade. So in a practical world, unfortunately, we're stuck with 2 degrees C as pretty much the minimum. But at the same time, I think we should bear in mind that we have already failed at that, and we should be honest with that to ourselves, amongst ourselves, and of course with others. So let's stick with 2 degrees C. It has this significant political momentum behind it. And then ask, well, what level of mitigation, what level of carbon reductions must we bring about to stay at or below 2 degrees centigrade? And then another important question that goes alongside that myself and colleagues in the Tyndall Centre have worked on for quite a few years now is, how do you split that global cake between the Annex 1, the OECD, the wealthier, the sometimes called developed parts of the world, and the non-Annex 1, the non-OECD, the developing and less wealthy parts of the world? How do you divide the cake of emissions between those two regions? And that's also hugely important and has significant repercussions, as I'll show as we go through this. So let's think first about emission reduction targets. What are we familiar with? Probably all of you have heard something like these, where we have long-term reduction targets, large reductions. The UK will make an 80% reduction in its greenhouse gas emissions by 2050. The EU will do something similar, and the international negotiations in Bali, 50% reduction by 2050. 2050, I think it's a term for not in my term of office. The politicians will not be there anymore. We as the public really like this because it means we can carry on doing what we're doing and we can pass the problem on to our children. Companies like it because they haven't got to worry about it for their immediate investments. So as a global society, we really like the idea of long-term targets. The problem can be solved with technology by someone else sometime in the future. And that's really what's informed much of climate change so far. Unfortunately, it has no basis in science, despite the fact many scientists have used that sort of shorthand and continue to use it, but they shouldn't. The CO2 that we put out into the atmosphere today will be there changing the climate for the next 100 to 200 years. So if you're sat under the light now, or if you're sat watching this presentation on any device that's using electricity, then you are changing the climate today for the next 100 to 200 years. So CO2 is there in the atmosphere for that sort of period of time. So a 2050 reduction target is unrelated to dangerous climate change, is unrelated to temperature. What matters absolutely clearly from the science, and there is no doubt about this, the only thing that matters for the long-lived, the gases that last quite a long time in the atmosphere, such as carbon dioxide and many of the other greenhouse gases, is their cumulative quantity in the atmosphere. How much are they building up to in the atmosphere? So every day that we put the lights on or we drive a car, we're putting carbon dioxide in the atmosphere, and it builds up on day in, day out. It gets more and more in the atmosphere. And that cumulative emissions, that carbon budget, is what is absolutely pivotal to understanding temperature and climate change. And it unfortunately rewrites the whole chronology, the whole timeline of climate change. It takes us from long-term gradual reductions where technology can solve the problem in 2030 or 2025 or beyond, to urgent and radical reductions that we need to bring about this afternoon. And obviously that's much less attractive. So you can see why it is we don't want to think about cumulative emissions. We'd much rather stick with the scientifically illiterate long-term targets. Because as soon as we bring the science into this, it tells us something that we're not really prepared to countenance, we don't want to hear about, that we will have to make changes today. So how does this scientifically credible approach change the challenge that we now face in terms of mitigation? Well, first, let's think about the latest emissions data, and what does that say about the global problem that we're now facing? Well, it's absolutely clear that things are getting worse, and they're getting worse at an incredibly fast rate. You can see here a plot of global CO2 emissions, so you can see the graph going up. And what's worrying, of course, you can plot this for everything. It can be population, plasma screen ownership, how far we drive, how many cars there are, how many refrigerators there are in the world, how big refrigerators are. Everything about human beings fits into this exponential curve pretty much. And we would know that if any other species did that, we'd say, well, it's a genetic cul-de-sac, it's going to come to an end very soon. And somehow there's a certain arrogance about collective human society that says we can do this with absolutely everything, and somehow we're clever enough to defy almost the laws of science and physics. You cannot keep doing this as a species. We are doomed if this is the case. But this is what's been happening so far in terms of CO2 emissions. The last 100 years, the last century, the emissions grew of carbon dioxide at about 2.7% per year over that 100 years. And of course, the Earth Summit was in Rio in 1992. Throughout the 1990s, we were talking a lot about climate change. And then the early part of this millennium, of course, there have been lots and lots of discussions on climate change. So you would expect the emissions rate to be going down, but actually it's gone up. If you look between 2000 and 2007, the rate of growth per annum was 3.5% per annum. That's a big increase from 2.7. So despite all the rhetoric, all the discussion on climate change, perhaps as climate change scientists and politicians are flying around the world to various conferences and meetings, they're causing the fact that there's been this big rise in the increase every year of carbon dioxide. And remember, of course, the rate is going up, and every year it's going up from a larger number. So this is a move in completely the wrong direction. We've had an economic downturn now, which was nowhere near as big as many people thought in terms of emissions. They dropped by about 1.3% because of the economic downturn globally, but it was hardly affected India, China, and the poorer parts of the world. So what we're seeing now, with the latest data, suggests that emissions in 2009-2010, this is from the International Energy Agency, went up by 5.6%. 5.6%. That is a massive increase in the level of emissions. Now, that might be a small part of that, might be a blip that we've come out of this economic downturn, and the activity is such that you'll see it a little bit higher for the first year or two. But the underlying message is that we're much more likely to see higher rates of increase as the non-Annex 1, the developing parts of the world, particularly driven by China and in India, producing goods, of course, that we consume over here in the West, that these parts of the world will be driving up the emissions because they use a lot of energy, they do a lot of manufacturing, and a lot of that energy is coal-based. So it's not unexpected that we would not be surprised if we start to see 4 or 5% per annum increases in emissions year on year from this year, from 2011. So we are going in completely and utterly the wrong direction, and we're going there faster. So we're accelerating towards the cliff that we know is there. So what does this failure, and I think it's fair to call it an abject failure to reduce emissions, when it's allied with the science on cumulative emissions, what does that say about what we need to do, the emission pathways? So this is what policymakers need to know about what sort of pathway going out into the future. What do I need to do year on year? What does that look like? Well, firstly, the earlier we can peak emissions, in other words, the earlier emissions can reach their highest before starting to come down, the better. Because if you can reach the peak sooner, then depending on a few other factors, basically it means you don't have to come off the peak quite as fast as you otherwise would have to. And coming off the peak is extremely difficult, because that's when you need to be reducing your emissions every single year, whilst for most countries trying to grow their economies. So the earlier we peak emissions, the better. You'll see here in these set of graphs, these are taken from a paper that myself and a colleague, Alice Bose, had published by the Royal Society in 2008. These are pathways, and what's important about them, the numbers don't matter too much in here, but what you can see is that the emissions starting from 2000 are going up, and you see the emissions on the vertical axis, you see the emissions of carbon dioxide, and on the horizontal axis you see the years out to 2100, and you see emissions going up there, and then you see them reaching a peak, and in this case in 2015 where emissions globally reach a peak and start to come down, and you see a set of curves there because there's a lot of uncertainty about the science, so you always need to see a different set of cumulative emissions. Now, as I said before, the message is really about cumulative emissions, and cumulative emissions relate to the area under that graph. So the bit under the lines are what matters. And you'll notice that as we hit 2050, 2060, it almost goes horizontal at a certain level. And that's because we've assumed emissions by then, well, they would have to be down to zero from almost all activity except for feeding the world's population. You cannot feed the world's population without emissions of greenhouse gases. And with the 9 billion population, we've assumed here big improvements in efficiency for agriculture. But even if you make the tractors all carbon-free, the process of using fertilizer and the process of growing things, of even just ploughing the soil, will put greenhouse gases into the atmosphere. So there's nothing you can do about that above a certain level. You will always get some. And that, of course, reduces the emissions that we can put out in the interim from energy. Now, 2015, of course, is when Stern, in the Stern report, which many people will have heard of, actually had emissions peak globally. 2015, in the next 4 years. So let's think, some of us may think that 2015 is perhaps a little early and not very realistic. So you may think, well, a 2020 peak is more viable. And what you'll see here is that the emissions have to come down a little bit steeper after the peak. More obvious here, if we say emissions peak in 2025, you have to come down even steeper. You'll also notice there are less lines, and that's because the further you go into the future, you've already started to exceed some of the cumulative emission budgets that some of the science suggests you have to have for 2 degrees centigrade. So you have to now be on the quite lucky end of the science. The later you leave the peak, the faster you have to come down, but sometimes you'll already have exceeded the budgets that some of the science related to 2 degrees centigrade. If you look at one of these in a bit more detail, the one in the middle here, the 2021, for around about 50-50 chance of 2 degrees centigrade of avoiding what we traditionally thought of dangerous climate change, you can see the curves here. Now, the easiest set of curves there are still reduction rates of about 10% every year. So every single year, from when we hit a peak in 2020, we'd have to reduce emissions at 10% year on year for about 2 decades, to give us what really is not a very good chance of avoiding something we've classified as dangerous climate change. So this is not looking particularly promising. But if you then go a little bit further than this and say, right, okay, we've got food emissions in there, we've got some deforestation emissions in there as well, and we've assumed very optimistic deforestation changes. So we're assuming here that very rapid reductions in the levels of deforestation. But as we deforest, we keep putting CO2 in the atmosphere, which will be there for 100 to 200 years. So you have to think about that in relation to what we might have left for energy. So if we remove the emissions from food, and remove the emissions from deforestation, and that's what's left for energy, firstly, most of the science says it's too late. If you peak in 2020, the emissions from food and the emissions from deforestation means there's nothing left for energy. So you have to be on the really very optimistic end of the science. And even then, what you see is emissions from energy around the world. That's from our planes, our cars, our heating, everything that we do, all of our appliances, everything in our life in terms of energy has to be zero carbon by 2035 to 2045. Zero carbon. That doesn't mean 5 or 10% carbon. That means zero carbon, to give us what is really quite a low chance of avoiding 2 degrees centigrade. And the reduction rates there are 10 to 20% every single year from 2020 from the energy system. So, well, that may not mean much to you, 10% per annum or 20% per annum, but just to give some sort of handle on what those numbers are. If you look at the Stern report, annual reductions of greater than 1% per annum have only ever been associated with economic recession or upheaval. That's what Stern noted in his report in 2006. The UK had a big shift to gas-fired power station, and the French had a massive increase in their nuclear capacity. These weren't for climate change reasons, but these are both very lower carbon energy systems, and yet they only went along with a very small reduction in their global emissions from those countries because those countries' economies grew. So despite the fact they shifted to low carbon, their emissions hardly went down at all. And once you factor in the emissions from aviation and shipping, which are currently not under the Kyoto Agreement, once you factor those emissions in, the only examples we have of significant shifts to low carbon energy did not have any reduction in emissions. They reduced the rate of growth temporarily of emissions. They had no net reduction in emissions. And this next one here, the collapse of the Soviet Union, I'm not recommending this. I'm not saying this is a good policy mechanism to bring about, but I'm just pointing out that the collapse of the Soviet Union economy managed to achieve, for about 10 years, a 5% per annum reduction. So when the collapse of that economy occurred, it managed to achieve about half to a quarter of what we would say was necessary to give us a 50-50 chance of 2 degrees centigrade. So as you start to see, this is not particularly upbeat, that we have no precedents out there. We have no idea how to get to this 2 degrees C desired future. So why does this sound different from the standard analysis? Well, firstly, and I'll come back to some of this later, virtually all of the analysis that is out there has emissions to a peak level growing at only about 1 to 2% a year, when in reality it's growing at nearer 3, 4 or 5% per annum. So the growth rates are far lower than is actually happening in reality. The Committee on Climate Change is a good example of this, but you look at this around the world, almost all analysis shows the same. The real growth rate is 3 or 4% per annum. Virtually all analysis peaks emissions between 2010 and 2016. The Stern report was 2015. The UK Committee on Climate Change has its work premise on 2016. The Adam report recently came out for the EU had 2010. So 2015, sorry. So wherever you look, people are assuming very early peaking dates. So they're assuming very low growth rates in emissions to a very early peaking date. And you can look around you. You can see the emissions that are occurring globally, and you think, is any of that in any way, shape or form a good illustration of the real world in which we live? And if not, then you may start to think, well, why is this analysis different? The UK's Committee on Climate Change, who are doing much more than the UK is doing much more in this area than many countries around the world. But even there, the assumptions embedded in that report have China and India peaking their emissions in 2017. But no one's ever spoken to the Chinese or the Indians about that, and I'll come back to that later on in this talk. The rate of emission reduction that we're suggesting from our analysis is an order of magnitude more challenging. So we're talking about 10 to 20% per annum, as most people are talking about only 2, 3 or 4% per annum reduction in emissions once you've gone over the peak. So that's a completely different way of looking at it. Most of the analysis out there says, oh, technology can solve the problem. Though very seldom are these people engineers that are saying this. The arguments we make is that supply technology, you cannot put it in place fast enough to bring you off the curve quick enough. That's not to say it's not important. In fact, it's a prerequisite of getting to a low carbon future. But it will not do it in and of itself. You have to have radical reductions beforehand, and technology cannot deliver those, particularly the supply technologies. Perhaps the demand side can do, and certainly behavioural can move you much faster. But you simply cannot get the big supply technologies in place fast enough in the wealthier parts of the world. Those of you familiar with Sokolov's wedges, they're the wrong way around. This is where he divides the world's emissions into different sectors and then has them starting from a small level of a wedge, small pointy end of a wedge, going to a big part of a wedge. Well, that's fine if we started these issues earlier, but because we're so late in addressing climate change, we need to get big reductions almost immediately, and we'll see diminishing returns as time progresses. So those wedges are really the wrong way around. And very challenging this, I think, that really net costs are meaningless. This tells us a lot about the economics of this and the finance in particular, that we are working in a non-marginal world, and by that I mean very large changes. Whether it's in mitigation, the rates of change are very large, or whether it's in adaptation, the impacts are going to be very big, and what we'd have to do for adaptation are very large. Economics is fundamentally premised, market economics, on small changes. And we're no longer talking about a world of small changes. We're talking about a world of very large changes. So in physics, we use Newton's theories to understand how the car works. But if we go to the subatomic particles, we use quantum mechanics. We use different theories. Economists tell us we can use the same theories regardless of the scale of the problem. That simply is wrong. We are now working on non-marginal, very large changes occurring very rapidly indeed, and market economics cannot address those sorts of problems. That's not to say costs, and particularly prices and market economics, can be helpful in niche parts of climate change, but they cannot be helpful to overall address the issues. So that's why it's all very different. And it all looks extremely difficult. So it's very easy to sort of throw your hands in the air and say, well, that's impossible, we can't do any of this, so we're going to have higher temperatures. Well, fine. But let's look at higher temperatures. Let's imagine we head towards a 4 degrees C future. Is 4 degrees C, can we hold at that sort of level? Well, firstly, the reduction rates, if we peaked emissions around about 2020, if we then came down from the peak at about 3.5% per annum at rates the economists tell us are roughly possible with the growing economy, all of that is achievable. Then you can say, well, okay, 4 degrees C, we can hold at that temperature apparently. We can make reductions that are necessary for that. Is that more realistic? Well, let's just think about 4 degrees C as a global mean surface temperature. Immediately it doesn't sound too high, but it's actually 5 to 6 degrees as a global land mean, because as I say, most of the world is covered in sea, and that will take a lot longer to warm up. So the land will be warmer than the oceans. And you start to think, well, what's that mean on, say, the hottest days of the world? Then we start to think about when the impacts are that affect us around the globe. Well, in China, we'd be seeing increases of 6 to 8 degrees on the hottest days in China. Now, China is already struggling in some of its cities in the really hot days. In Central Europe, we'd be seeing 8 to 10 degrees in the hottest days. Can you really imagine putting that on top of the 2003 heat wave? In New York, 10 to 12 degrees. I wouldn't like to use the subway when it was 10 to 12 degrees warmer in New York. These are temperatures that our infrastructures, our ways of living in these parts of the world, are simply not attuned to. There is nothing that we know about the structures that we have that would allow us to live with these sorts of temperatures without some real dire repercussions. And at low latitudes, 4 degrees C gives you something like a 30 to 40% reduction in the major staple crops, maize and rice for instance, whilst at the same time the population heads towards 9 billion. So there's a 4 degrees C world. There's just a snapshot of a 4 degrees C world. And I think it's fair to say, in discussion with a lot of people on this over quite a long time now, that there is a widespread view that a 4 degrees C view is incompatible with any sort of organised global community. We might have little pockets of society still surviving, but in the way that we see an organised global community, that looks impossible. It's also beyond what many people think we can reasonably adapt to. So rather than reach for discussions and trying to sort out what we might do about limited water or food, we may all end up reaching for the Kalashnikov. We do not always adapt to things that occur around us in a rational and reasonable manner, and 4 degrees C may well be pushing that too far. It's also devastating for many, if not the majority, of ecosystems. And beyond this, 4 degrees C has a reasonable to high probability of not being stable. In other words, we would go through 4 degrees C, we would set in train other feedbacks that some people call tipping points, that may well then take us to higher and higher temperatures. So we may not hold at 4, it could be 5, 6, 7, 8, or whatever it might be. So it could be much, much worse than 4. And consequently, I think it would be fair to say, and I've heard this certainly from some of the main directors on the Committee on Climate Change, that 4 degrees C should be avoided at all costs. Now, this has all been fairly bad news, and it's about to get worse. And this is about to get worse if you live in the wealthy parts of the world. How do we split this cake, this emissions cake, between the developed and the developing, the non-OECD, the non-Annex 1 parts of the world, the poor parts of the world, and us in the wealthy parts of the world? I'm going back to here to a few more graphs that were underpinned a paper that I wrote with my colleague Alice Bowes and was published again by the Royal Society earlier this year, in January of this year. And this is for around about a 40% chance of exceeding 2 degrees centigrade. And what we wanted to do was to think, well, what is possible? How far can we push the non-Annex 1 countries in terms of their emissions? And then see what's left for us. What would be left for the Annex 1, the wealthy parts of the world? So the non-Annex 1 here, if you think of the developing countries, and what would be left for the developed countries, for the wealthy parts of the world. Well, what we had here was, firstly, well, you can see the little dip there for the economic downturn, which was hardly felt in the non-Annex 1 parts of the world. We then see emissions growth here, out to a peak in 2020 of 3.5% per annum, 3.5%. That's much lower than we're actually seeing in the non-Annex 1 parts of the world, in China and India and so forth. They're growing at much, much more rapid rates than this, nearer the sort of 6, 7, 8% growth in emissions. So this is hugely challenging for those parts of the world. We see it peak here, 2025, not 2020 as I just said. We see emissions here peaking in 2025, which is very early, and I'll come back to that in a minute, for these parts of the world. And then coming down at 7% every single year, which is twice that Stern and most economists have said is possible within a growing economy. So this is hugely challenging. You then work out the area under that curve, and then you say, well, we know how much we're allowed to put out globally for 2 degrees C. So what's that leave for us in the developed part of the world? And then you plot that out, and it looks like this. In other words, in 2010, we have no emissions left. We would have to switch the lights off today, or we should have switched them off yesterday, not drive home. When we get home, turn the refrigerator off, the computers, never fly anywhere, and have no more emissions from energy. So there literally is nothing left for us for a 40% chance of staying below 2 degrees centigrade. That's us peaking in 2010, coming down at an infinite rate. That's challenging to say the least, but even this non-Annex 1 pathway, some would argue, is too optimistic. And I've just returned recently from a visit to China, where I spent a lot of time talking with energy and climate change analysts there, trying to understand what is actually happening in China in terms of emissions. And I want to say a few things about China and India, because I think it underpins some of the naivety that's driven a lot of the Western ways of looking at these issues, which gives us cause for concern for someone like DFID, when it means that the futures are likely to be seeing much higher temperatures, which are very important for issues of development. China's emissions are currently 7.5 gigatons, 7.5 billion tonnes of CO2, which is about 25% of the global emissions. The growth rate from their GDP has a 10-year trend of about 10.5% per annum, and some economists have said it may come down. Economists told us 10 years ago that wouldn't be possible, but they've achieved it in China. So maybe it will come down, maybe it won't, but the Chinese are not planning for it to come down, and they've been very successful at maintaining that for a long time. India's emissions are about the same as Japan, about 6% per annum, and they've been growing at about 7.5% over the last 10 years. So again, very high growth trends in India as well. The emissions are considerably lower than China, but still very significant indeed. Can this continue? Shanghai and Beijing have the same GDP per capita as the OECD. But there are 200 million people in China that earn less than $1.25 a day. There's about another 350 million people in China on between $10 and $20 a day. So there's a huge scope for people there for low income industrialization, if you like, people who can move often from the rural environments into the urban environments and be driving the economy and industrialization there. The Chinese GDP per capita, measured in the market exchange rate, which is not the perfect measure to use for this, but for today it's fine, is about 5% of that of the OECD. So although places like Shanghai and Beijing, which collectively have a population of about 2/3 of that of the UK, are as wealthy as we are on average in the UK, the average Chinese person has only about 5% of the income as the average OECD, the average Brit, if you like. If we then think about India, India's income per capita is even lower. It's only about 2% of OECD. So there's huge scope for these countries to become wealthier and wealthier, moving towards the position we're in. It's also interesting to note that India's GDP per capita is only 1/3 of that for China. So the average Chinese person is already 3 times better off than the average Indian. And the Indian population by 2015 will be very similar to the Chinese one today at about 1.3, 1.4 billion. So there's huge scope here for continued growth in the economies and the incomes of these countries, and for low wage industrialisation. It appears to me there's no real argument for saying that they cannot continue at very high growth rates, and the emissions that could accompany that could see us going well beyond those that we're currently embedding in our models. So if China meets its 12th five-year plan and its other promises to reduce its emissions intensity, emissions per unit of GDP, then what we're looking at by 2020, and I think this is very likely to be the case, that China will represent about 50% of the world's CO2 emissions compared with today. And if it carried on at that rate, and we've got a lot more opportunity for changing things between 2020 and 2030, by 2030 China's emissions would be the same as the rest of the world is today. That's for one country. Are these numbers reasonable? Well, I spoke to a lot of Chinese academics and experts, those that advise the State Council to the People's Republic of China, most of the major energy groups within the universities there, and other people as well who worked in this domain within China. And the Chinese expect emissions to peak in 2030 and probably then plateau. 2030. The minimum growth rate to peak was seen to be about 7%. There was a bit of an outlier. Some people thought it might be nearer 5%, but still much higher than we're normally considering. And after the peak, they thought it would come down at somewhere between 3.5% and 5% per annum. So, are these absolute numbers that I came up with before, the total emissions from China, are they reasonable? Well, the Chinese seem to think so. But most Western modelers and scenario builders imply that they're not. So in their models, they don't embed any of this that's occurring in China. And yet, if you talk to the Chinese, they think what they're saying is completely reasonable. And to me, it seems that they've got a much better handle on emissions than most of us in the West doing the modelling. I won't go into any detail here, but if you add India to this and assumed it would follow a similar pathway to China, then India's emissions by 2020 would be about 3.5 gigatons, and by 2030 could be as much as 6.87 gigatons, a very significant increase in emissions. And are those numbers reasonable? Well, I haven't spent a lot of time talking to Indian experts, but I have spoken to quite a few. And most Indian experts in climate change suggest that the energy emissions from India will peak after 2030. And most Western modellers, again, do not embed that in their models. You put these together and you say that by 2020, just by 2020, India and China could have 2/3 of the global emissions compared with today. We're supposed to be reducing emissions today. This is on top of the rest of the world. They will peak probably about 2030. They have about 40% of the global population. Their GDP per capita for the countries put together is less than 5% of that for the wealthy parts of the world. And their growth rate is about 9% per annum if you put them together. So this is a completely different world. Does it really matter? Well, currently no global modelling of scenarios takes serious note of India and China. The Committee on Climate Change Analysis is premised on these countries peaking by 2017. They don't think there's in any way, shape or form viable in India or China. And all of the low-carbon integrated assessment models that we can find that are informing governments around the world have peaks between 2005 and 2016, which I think anyone who works in this domain will say is completely unrealistic. Clearly the ones in the past are. And they only grow emissions to the peak of about 1 to 2% per annum, when it's growing at much nearer 4 or possibly even higher percent per annum. So does this matter? Well, the first impressions are the numbers from China and India and I've outlined here, or anything even approaching those numbers, have fundamental implications for mitigation and from a different perspective here from adaptation analysis and policy. This is both globally and indeed for all nations around the globe. So let's go back to 2 degrees C against this. There's a whole, I would argue, a political and a scientific creed behind this. If we look at what we often hear, and this is where my concerns often arise from, that people are talking about climate change in quite an abstract way from what I would call as reality. So this is the orthodox view I'm talking about here at the moment. This is from the void work that's going on in the UK. It is possible to restrict warming to 2 degrees C or less with at least a 50% probability. That sort of language is being used to inform policymakers. This is from the Committee on Climate Change, their 2009 report, and there's not much difference for 2010. 2011 rather, their fourth budget report. For 2 degrees C, it is necessary that the UK cut emissions by at least 80% by 2050. The good news is that reductions of that size are possible without sacrificing the benefits of economic growth and rising prosperity. And then the Adam report, which was published looking at the EU, talking here particularly about the EU, a low stabilisation target of 450 parts per million CO2 equivalent of those greenhouse gases, and that's a very, very low level, we're roughly at that level now, can be achieved at moderate cost with a high likelihood of achieving this goal. That's the sort of can-do language that's being provided to our governments. This is what we used from this is a quote from the paper that Alice Bowes and I wrote out in 2008, using the same science as those other quotes. So all using the same science here. It is difficult to envisage anything other than the planned economic recession being compatible with stabilisation at or below 650 parts per million CO2e, in other words, about 4 degrees centigrade. In our more recent paper, 2011, the 2015 and 2016 global peaking date, which Stern, the Committee on Climate Change, the Adam report use, implies a period of prolonged austerity for Annex I nations and a rapid transition away from the existing development patterns within non-Annex I nations. In other words, prolonged austerity for the developed, the OECD, with wealthy parts of the world, and changes to development patterns within the developing parts of the world. So these are radically different interpretations of the same science, and I've tried already to show why it is that some of those differences may arise. But in summary, in terms of the differences from those two views, historical emissions, I would say, have sometimes been mistaken and been deliberately more provocative, possibly massaged in some of the more common or orthodox analysis that's out there. The short-term emissions growth are seriously underplayed, downplayed within virtually every single model we can find, low-carbon model out there. Their peak year choice is Machiavellian at worst, but even at best, even if it isn't Machiavellian, it's dangerously misleading, the idea we could peak in these sort of very early dates. The reduction rate is universally dictated by economists, and that is absolutely pivotal to why this analysis, we would argue, are so unrealistic. The reduction rates in the future dictated by economists. The emissions floors, in other words, the emissions from food, are poorly understood, though the UK government and the Committee on Climate Change deserve considerable credit for trying to embed that in their work, as others are not so much. Geoengineering, ways that we can use Harry Potter's wand and very large bits of Dr. Strangelove engineering to reduce carbon emissions. Now, they may end up being viable options in the future, but the idea we're embedding them in almost all low carbon analysis at the moment, we're putting them in as if it's the same thing as switching the light off. It's not. We do not know about these sorts of technologies at the moment. We may know about them in the future, but they are very speculative at best. So we should not be embedding them in most of our analysis. So whilst perhaps Harry Potter is pushing it a little bit, at the moment these are on the absolute fringe of our understanding, and it is unreasonable and irresponsible to embed them in so many of our carbon models. The split between Annex 1 and non-Annex 1, the split between the developed and developing world, is often neglected or hidden in most analysis. And there are huge optimistic assumptions about big technologies coming forward. And I'm a mechanical engineer who spent a lot of my life working on rigs in the North Sea, on large bits of engineering kit. I like engineering as a solution to a lot of issues, but we cannot do those things fast enough, and there's a misunderstanding about how successful big technology can be. And we have a magician's view of time and a very linear view of problems. We think that 4 degrees C is just 2 times 2 degrees C. We think if we don't do something now, it's okay, we can do it in the future. Well, that doesn't work with climate change. It's a cumulative problem. If you don't do it now, we are embedding the future to certain levels of climate change. All of this is very despairing, but I think it's important that we don't despair. And a lot of the work we've done in the Tyndall Centre, particularly those of us who work on the energy field up in Manchester and some of our colleagues down in Sussex, we would suggest there is agency. There are things that we can do to move us towards 2 degrees C. Okay, an outside chance of 2 degrees C, but at least in the right direction. And I think it's really important to bring those bring those home, that we can do something. First, let's just think about what we need to do. If we put some of this analysis together, what we're asking for is about a 40% per annum 40% reduction in emissions by 2015, 40% by 2015, a 70% reduction by 2020. And something like a 90%, or basically 100% reduction from energy by 2030. That's the sort of reduction rates we need to be seeing, certainly within the Annex 1 countries, if not heading for those globally. But these are very different from the sorts of numbers we traditionally think, because most of the analysis out there is, as I said before, is underplaying current levels of emissions and emission growths. Now, people are simply turn around and say, well, that's impossible. Well, okay, if that's impossible, is living with 4 degrees C global temperature rise by 2050 to 2070 less impossible? The future is impossible from the way we see it today. We say we cannot mitigate at these rates. Well, at the moment we say we also cannot adopt to the temperatures if we don't mitigate. So there is no easy way out of this, and we should not keep pretending that we are awash with win-win opportunities or green growth opportunities here. This world is a world of very difficult futures which we have to contemplate. But the sooner we contemplate these futures, the sooner we can do something about them. So what can we do? Well, the first one we'll look at is to do with equity, and the second set we'll look at technology. So both of these, just to give us some sort of illustration, then there are lots of others out there as what we could actually do. And let's think about the equity one first. There are around about 6.85, 6.9 billion people on the planet, quite quickly heading towards 7 billion. But how many of those people really need to make a change in terms of their emissions of carbon dioxide and greenhouse gases? I'm not talking about broader sustainability here, just talking about climate change. When I think of the Pareto rule, Alfredo Pareto's 80-20 rule, as an engineer we used to use this all the time, a rule of thumb. 80% of something relates to 20% of those involved. 80% of emissions come from broadly 20% of the population. And that roughly holds quite well within different nations and indeed globally. If you then look at the 20% of the population and ask, well, what about 20% of that 20%? And you do that twice more. what do you find? Well, about 50% of the world's emissions come from about 1% of the world population. Now, these are very rough. They're a guideline. It could be 2% of the population is responsible for 40% of emissions, or 1% for 60% of emissions. But this broadly seems to hold when we look at emissions around the globe and within particular nations. So it gives us a handle that emissions actually come from quite a small percentage of that 6.85 billion. And they're the ones we need to target our concerns about. And what you often will hear, oh yes, but the Chinese and everyone else are trying to have, everyone wants a fridge and a car. True, they may want a fridge and a car. But by the time the mode person, not the mean, the mode person, the normal person in China, actually achieves getting a car or a fridge, we will have had to have had a low carbon energy system in place. It will take them 20 or 30 years, even at 10% per annum growth rates, to get them to that level. So the poor cannot grow fast enough to really affect the basics of this maths. We know the people emit, and it's people like me. Who's in the 1%? Well, virtually, there may be the odd exception, but I would say every climate scientist around the globe, every climate journalist or anyone who pontificates about climate, any OECD or other academic, pretty much I would suggest around the globe, is probably in that 1%. Anyone who gets on the plane once a year will put himself in the 1%. In the UK, anyone earning towards £30,000, it could well be less than that, will be in that 1%. And many people, of course, are aspiring to be in that 1%. So that's the group in the 1%. And then you have to ask, are we, principally in Annex 1 countries, the wealthy parts of the world, developed parts of the world, but not only, or about probably 200 to 300 million Chinese are in the same group, are we, the 1%, sufficiently concerned to make or have enforced through legislation and regulation substantial personal sacrifices and changes to our lifestyles now to help the rest of the population and indeed the future generations? Are we prepared to have that now? And if we're not, then what we're saying, we're prepared to countenance and accept a high probability of a 4 degrees C future. So there's no easy way out of this, and we shouldn't pretend that there is. That's the question we, the 1%, have to ask ourselves. But it does give us some agency. It does say, well, we know who needs to change, so policies need to be aimed specifically at them. So actually it gives us real hope. What might some of these policies might look like? What can technology do to help? I'm going to give a couple of examples on technology. The first here is about the electricity system. If you're sat in a room now with a light on, if it's a traditional light, incandescent light bulb, which it may well be, you'll need some electricity to light that light bulb. Even if it's a compact fluorescent light bulb, that's also true. You'll need a transmission network, some pylons and wires and so forth to get the power to you. You'll need a power station to generate the electricity. And you'll need someone in Venezuela or Colombia or Australia to dig the coal out of the ground for you, or for us, and or get the gas out of somewhere in Russia and export it all the way over to our power station. If you start to put some units on that, if you have a normal light bulb, an incandescent light bulb, then if you want 10 units of, say, useful light, the light bulb itself is very inefficient. You'll need about 50 units of energy going into it. You'll lose 6 to 8% of your energy in transmission and distribution. Your power station will be running at somewhere between 35 and 45% efficiency. In other words, most of the energy going in the power station will go up the chimney. And you'll lose about 10% or so of the energy in getting the fuel out the ground, putting it on a train, taking it to a port, bringing it across the sea, into another train, back along to the power station, to go in the power station, doing that every day of the week for the 40-year life of a power station. So you start to see there that the demand opportunities, what you can do on the demand side, they dwarf the supply side. You can do this for cars, you can do it for refrigerators, you can do it pretty much for all of the things that we do. Demand opportunities dwarf supply, and we can change demand in the very short term. Toasters have a 1 to 2 year life. Cars, really, as I'll come to in a second, about 8 years is what we're talking about for cars. So we can, and refrigerators and many white goods are between 3 and 8 years. So we start to see real change could be brought about very rapidly from a regulatory framework in terms of that. Let's just think about car efficiency here. The average car in the UK emits about 175 grams of carbon dioxide for every kilometre it travels. A new car on a forecourt is about 150 grams. In 2015, the EU planned to introduce legislation whereby it will be 130 grams, will be a fleet average. The wealthy will be able to buy their way out of it and still be able to buy prestige brands, and you'll still be able to have some four-wheel drives, because as long as Nissan or Renault sell four-wheel drives, they'll have to sell some more efficient cars as well. So it's only an average, this. But in 2008, in fact, BMW introduced the 3 Series 160 horsepower diesel engine. It's a quite sophisticated diesel engine, but it's a diesel engine. It's not a hybrid. It's not an electric car. It had only 109 grams. It's a fast sort of car that, particularly, a lot of men generally like these sort of vehicles. So it's a sort of typical sort of fast, sporty 4 or 5 seater saloon type car. But you have more normal cars like the VWs and the Skodas that even in 2008, 2007 and now in 2010 and 11 are producing 85 to 99 grams per kilometre. In 1998 the Audi had a car that only did 75 grams per kilometre. It still did 75, 80 miles an hour on the motorway. It still did everything else a normal car does at only 75 grams. 90% of all the vehicle kilometres that are travelled by cars that are 8 years or younger on the roads. So if you start to put some of this together, what you can say here is without electric cars, without hybrids, just with standard diesel engines tweaked for performance in terms of efficiency rather than performance in terms of speed and so forth, if we had that and we constrained vehicle kilometres from growing, and they're not growing much in somewhere like the UK, we could see a 50% reduction by 2020 with no new technologies. On top of this, of course, you could have new technologies. If we then reverse the recent trends in occupancy, so in other words, we have less people per car than we used to have, we could probably see something like a 70% reduction by 2020 from cars. We could still drive in cars, we still drive cars as much as we drive them today. This is not a big shift to public transport, which would help the situation. It's not a switch to electric cars, which may well help. This means decent legislation using existing technologies. There is huge scope, whether it's for cars or refrigerators, across the board to make radical adjustments with the appropriate legislation to bring emissions down in line with what we needed to have before. So to conclude, what I hope I've shown you now are some really upbeat messages. But let's remember what we're talking about here at the moment. If we have some relatively conservative assumptions about where we're going, then the conclusions are still very uncomfortable. If we're broadly right on the science between cumulative emissions and temperature, if the developing parts of the world can emit peak emissions by 2025 to 2030, India, China and so forth, if there are rapid reductions in emissions from deforestation, if we can halve emissions from food production, from food per capita that we have today by 2050, and currently they're going up, not down. If there are no discontinuities, if you like, these tipping points that are out there in the natural system, and if we can achieve the reduction rates that Stern, the Committee on Climate Change, the International Energy Agency are possible with economic growth in terms of reductions of CO2 emissions, if all of that is put together, 2 degrees C stabilisation is virtually impossible. Now, I've shown you that there are things that we could do, and that's why I think it's virtually impossible. The current political framework, the current economic framing of society makes it impossible. But it's not absolutely impossible. If we're prepared to make those sorts of levels of changes to the behaviour of the 1%, allied with the technical adjustments we can make now whilst new technologies come on stream and low carbon energy supply, 2 degrees C, an outside probability of 2 degrees C is still possible. That's a very upbeat, positive message. We have the agency to avoid the worst excesses of climate change if we're prepared to make those changes now. If we're not prepared to make those changes now, then we are heading towards 4 degrees C, and it could be as early as 2050 to 2070. The International Energy Agency, just before Christmas, was saying that they could envisage 3.5 degrees C by 2035. So we're no longer talking about the end of the century. We're talking about in the lifetime of many people on the planet today. In fact, most people on the planet will still be around probably by 2035. So we are talking about big temperature increases for many of us now, let alone our children. And of course, 4 degrees C is unlikely to be stable. It may well go well above 4 degrees centigrade. So where does this leave us? Well, in 2005, in Manchester, my colleagues there, we had this term that we use, which is now quite commonly used, I think, to mitigate for 2 degrees C and to plan for 4 degrees C. And we said that was what we felt was a more responsible way of looking at these things. We should do everything we can to hold emissions at 2, but if you're planning your infrastructure, you're planning your sewage network, your freshwater network, your properties, your houses and so forth, think what are the regional implications for 4 degrees C and plan for that. And that's hugely important for people like DFID. My colleague Alice Bowes made the point just earlier this year that actually we're doing something completely opposite. We're mitigating for 4 degrees C. In other words, we're doing almost nothing on reducing emissions, but we're only planning for 2 degrees C. And this is the worst of all worlds. That's where we're heading. We're really not thinking this through at all. Lots of rhetoric, lots of good words around, but that's what we're doing at the moment. We are embedding the future into a really dire situation because we're not prepared to make changes necessary or be honest about it. But I don't want this to come across as a message of futility. This is taken from our last paper. It is intended as a wake-up call as to where our rose-tinted spectacles have brought us. Real hope, if it is to arise at all, and I hope I've demonstrated in this talk there is some real hope out there, will do so from a bare assessment of the scale of the challenge that we now face. And that's what I've tried to do in this talk, and indeed that's what our paper's trying to do. We're not trying to be liked or disliked by anyone, we just paint it as we see it. It's very uncomfortable, the numbers are brutal, The hope is tenuous, but it still exists. So a final message of hope from Robert Unger, who I've used repeatedly for almost every talk in the last 5 or 6 years, because I think it captures what we need to do. At every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. The one thing we know about the future of climate change, it will be different. If we do nothing, then we'll be hit by the impacts and the adaptation. If we choose to mitigate to avoid the worst, then the mitigation will be very significant indeed. So the future is almost impossible. It's almost beyond what we can imagine and beyond what we have clearly seen before. So our role now is to think harder, to have greater clarity, have greater imagination, and to no longer keep saying that's impossible. So we need to be making the impossible possible. I'm trying to say that with a very upbeat tone, and I do actually think there is some real hope out there, but the hope is reducing significantly every day as this is a cumulative problem and emissions are going up. And let's not just forget where we are. What's the world we live in today? And this was me up until 2-3 years ago now. I used to live on my own in a 3-bedroom terrace house in the Peak District. I now live in a 2-bedroom flat. I've deliberately downsized, but it's a very nice flat, and no doubt in some parts of the world I'd have 20 people living in there with me, but I live on my own in a 2-bedroom flat. People in the UK heat their gardens when it's cold in the winter, so they can sit outside and have a beer. We do this in our pubs and our restaurants as well. We heat our gardens with gas heaters. We fit halogen light bulbs in our kitchen. We have groups of 10 of them in there. We used to have one incandescent light bulb. Much, much better, the old 1920s light bulbs, than this collection of halogen light bulbs. We have 2 tons of 4-wheel drives that transport 70 kilograms of flesh 3 miles to pick up a newspaper. We drive our children to school because we're concerned, of course, they may be hit by the cars driving around. We think it's reasonable for business tycoons to have private jets. We think it's okay for academics to fly to climate change conferences, and during the flight, seeing musicians flying to climate change concerts in the other direction. We celebrate the excesses of celebrities. Everywhere we go, it's all about excess, about consuming more. That's what we're all aspiring to. We think we have a right to fly and to drive when and to wherever we want. We think we should have year-round strawberries, hen parties in Prague and birthdays in Barcelona, double-door refrigerators and home cinemas, second homes, 2 cars, 3 TVs, and 9 billion people living on the planet. And we somehow think that we can reconcile all this with a bit of technology in 2030. We need to wake up to the fact that we're way beyond that now. We start talking about climate change, particularly in the 1990s. We've done absolutely nothing about it but talk, and now we need some action. If we do start to act appropriately, there is an outside chance that we could hold to 2, maybe 3 degrees centigrade. If we carry on deluding ourselves as we are at the moment, then we are heading and locking the future into really catastrophic temperatures of 4 degrees C or more. And that choice is with us today. So that, in the end, really is a message of hope. The choice is with us today. And on that note, I'll finish. I've coloured them here, as you can see, from sort of the white colours up towards red colours, and as usual, as you head more into the red, you're heading more into the danger zone. And you can see for this set of collective impacts, the difference as the temperature goes up, you enter more and more into the red zone. And what's happened is that the process of policymakers engaging with scientists, engaging with companies, with organisations, engaging across national governments, over time, we've come to think of this 2 degrees C guardrail. As above 2 degrees C is considered dangerous climate change, where the impacts are no longer not acceptable. And below 2 degrees C, we may not want those impacts, but we say we could just about live with those. We could tolerate that set of impacts. Now, what's really important is that first assessment of the impacts was made in the late 1990s and the early 2000s, and here you can see it's published in 2001. These were revisited at the time of Copenhagen in 2009, and what you see straight away is the science has come a long way. A lot more is understood about the impacts, and worryingly, a lot more of those bar charts now, those collective impacts, are red. So the impacts will occur at much lower temperatures than we thought before. And if you actually plotted what set of impacts we thought before was just about acceptable, if you plotted them now, you'll notice they occur at a much lower temperature. So as an academic who's not interested whether our work is liked or not liked, there is a very clear conclusion that comes from that. If 2 degrees C was dangerous before, the impacts now at 2 degrees C are much larger than we thought at that time. So, said internationally and nationally, is the goal of all of this climate change research and policy that we're apparently undertaking. So if we think now internationally, the Copenhagen Accord that came out of the major meeting in December of 2009, the Copenhagen Accord is very, very clear, and it now has over 120 countries as signatures to the accord. And it's to hold the increase in global temperature below 2 degrees Celsius and to take action to meet this objective consistent with the science and on the basis of equity. And I think that's really important. It's a very clear statement on the basis or consistent with the science and on the basis of equity. So this is a really important backdrop against which we can then think about what we need to do in terms of policy. But if we then go to the EU repeatedly makes statements such as this one here. The EU must ensure global average temperature increases do not exceed pre-industrial levels by more than 2 degrees C, and it says we must introduce the appropriate domestic measures to ensure that is the case. Or if we go to the UK's low carbon transition plan, average global temperatures must rise no more than 2 degrees centigrade. No, these are not a 50-50 chance of 2 degrees centigrade. Whether it's the Copenhagen Accord, the EU or the UK, they must rise no more than 2 degrees centigrade. And that is really important. That probability of 2 degrees C is actually there's a lot of smoke and mirrors around that. So people say we must rise no more than it, and then introduce policies which mean you've got about a 1 or 5% chance of actually staying below 2 degrees. So there's a big difference between what the language is saying and what the actual policies are doing. So the question is clear. How do we ensure a good chance of staying below 2 degrees centigrade? And I'll just quickly say what I mean by 2 degrees in case some people aren't so familiar with it. 2 degrees C is the global temperature rise compared to the pre-industrial period, and it's a global mean surface temperature rise. So it's basically looking at the temperature before we start to burn fossil fuels, and then as we burn fossil fuels the temperature starts to go up, and the argument is that we could cope with a global average increase of 2 degrees C. And that sounds, particularly if you live in the UK, that doesn't sound too worrying. You think, well, quite nice to be 2 degrees C warmer. The regional repercussions of that are very large. In the poles you might see up to 7 degrees or so with a 2 degrees C warming. You'll certainly see some very large changes in temperature around the globe in different regions for an average of 2. Remember that 2 degrees C, of course, is the whole globe, and most of the planet is covered in oceans, so you'll probably see a 3 degrees C or so on average on land, as I say, up to 7 degrees in the poles, with big changes in precipitation as well. So 2 degrees C will have much larger repercussions than we may immediately think when we think of 2 degrees C temperature. So why have we come up with this number of 2 degrees? Well, it has actually been talked about on and off for probably about 30 or 40 years now. But broadly, what's happened is the scientists have looked at the impacts related to 2 degrees and indeed other temperatures as well. And they've come up with what we could call a managerial tool. They've taken all of the work that's been conducted on impacts and pulled them together into 5 categories of impacts. And then they rise, but the rate of growth of emissions has gone up. So we have done absolutely nothing in relation to climate change over the last 20 years, and we need to be true and honest about that now in 2011. So that's the sort of backdrop to this talk, and the tenor will certainly be often quite downbeat, but I also think there are some real strong messages of hope about what we need to do and how quickly we need to do it, and that actually it is still doable. So what I'm going to try and do over the next 40 minutes to an hour is to explore the void and the rhetoric, between the rhetoric and the reality on climate change, particularly focusing on mitigation, on reducing our emissions. So we have a lot of discussion about reducing emissions, but what's the difference between that discussion and what we all claim we're doing as individuals, as companies, as nations, as a global community, and actually when you start to look at what is actually happening in terms of emissions, what's the gap between the two, and what can we do to bring the two together to remove that gap. I spend a lot of time talking to companies and organisations about climate change, and they'll say, oh, we're doing something about climate change, and I think it's important to say, well, what do you think climate change is? What are you responding to? And it's this sort of woolly, nebulous term, I'm doing something on climate change. I bought a slightly more efficient car. That has nothing to do with climate change if you drive it further. So we need to think quite carefully about what are we doing as organisations, as individuals, as governments about climate change. What are we responding to? And for me here, it's actually quite simple. I will simply use what we have.
Kevin Anderson, welcome. You are the Deputy Director for the Tyndall Centre for Study of Climate Change at the University of Manchester. And you are here to help us understand and defeat some of the challenges of climate change for doing our research and doing our programming.
Well, thank you very much. Well, I've called this talk Climate Change Going Beyond Dangerous, and I'm using that as an expression because in my view and the view of my colleagues and the conclusions from our work is that we are now in the process of going beyond what we have traditionally called dangerous climate change, and I'll define that and talk about that a little bit more during the talk. And if you like, the subtitle for this is Brutal Numbers and Tenuous Hope. The maths, the quantification behind what I'm talking about here is unappealing to say the least. The numbers are brutal, they're hard, they're not numbers that we want to hear. And if you look at those numbers and you start to translate those into what that means for us as a society, then you realise there's very little hope. There's tenuous hope of actually making substantive changes in the time frame that we have available. But we need to say that. If that's the situation we're in, we need to be honest about it. And then once we're honest about it, we have some hope of making change. If we're not honest about it, then we can do nothing. Or, of course, we can carry on with what we've been doing for 20 years. Cognitive dissonance, a fancy academic term for hypocrisy, where we stick our head in the sand and we pretend things are not going awry. And they clearly have been going wrong for the last 20 years. The Earth Summit was in 1992 in Rio, and all we've seen with emissions since then is them rise year on year. Not only